Hello, hello students. I am Dr.A.K. Sinha, Professor of Chemistry. Today I am going to discuss resonance effect. Last class I have discussed resonance structures. Now I am going to discuss resonance effect. The resonance effect is defined as the polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electrons present on an electron atom. Again you listen. The resonance effect is defined as the polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and a lone pair of electrons present on an adjacent atom. The effect is transmitted through the chain. There are two types of resonance or mesomeric effect. Resonance effect is also called mesomeric effect. Question is asked. Both are not different. Then there are two types of resonance or mesomeric effect designated as R or M. R means resonance, M means mesomeric. R or M. First, positive resonance effect plus R. Positive resonance effect, in shortcut it is written plus R effect. In this effect, the transfer of electron is away from an atom or subsequent groups attached to the conjugated system. In positive resonance effect means plus R effect, in this effect the transfer of electron is away from an atom or subsequent group attached to the conjugated system. This electron displacement makes certain position in the molecule of high electron density. This effect is in aniline. Aniline is the very good example. Always where electron will move, there electron density will be more, means that there it will create negative charge. Electron movement, the direction of electron movement, where it is moving, where it is going, that atom will become more negative due to more electron density. Best example is aniline, means in benzene NH2 group is attached. Benzene group is attached. NH2. Then N has a lone pair of electron and N is attached to benzene by single bond. Then it can give three more structure or resonance. It will give, means electron will move. How it will move? I am telling you. It is in total four. Four structure will be there. Then now easily you can understand that how electron is moving. Then I am telling you now, NH2 has lone pair of electron and NH2 is attached to the benzene ring through single bond. Then now here just to show the movement of electron, two curved arrow you can use. you can use or it is used. Then first curve it will show that lone pair of electron of ammonia is going towards a single bond between nitrogen and carbon. NH2 is attached to the benzene through single bond. Then lone pair of electron will come towards that single electron as that single bond, and it will try to make it double bond. Just only simply movement you can show by curve. That this curve will show that electron is coming towards the single bond. Okay, and next curve, other curve, what it will do, because when these two electron will come, lone pair of electron will come to the single bond between N and C. That time double bond, which was in benzene ring, first double bond, NH2 is attached to the carbon, and next to the carbon, left direction, any direction you can select, either left or right. Then suppose now it is the you can say left way. In benzene, in left there is a double bond. Then two double bond continuously can't be. Because carbon has maximum 4 valency. If it will be can say two double bond continuously, then total valency will be 5. That is the wrong. Hence what will happen, to maintain the covalency, 4 covalency of carbon, that double bond, that is a pi bond, that will break. That pi bond will break, and it will give to the next carbon. It will shift to the next carbon. Until double bond will be shifted, that movement of this lone pair of electron of nitrogen will not take place. That's why you can show it by two curved arrow. Then first only you have to indicate it. Now electron has not moved, only you are showing by curve that it will go to the single bond, and double bond will break pi bond, and it will go to the carbon atom, means second carbon atom. After that what will happen in next step, means second structure, now it will start. Second structure means what? Now first you have shown to the curve movement, that how direction only you have shown, but now second structure, electron moved means lone pair of electron of nitrogen moved. Now where it was the single bond between N and carbon, NH2 was attached with benzene, then there by single bond, then that bond will come now double bond, and that double bond it was there, that next carbon, that two electron pi bond broken, and that two electron was you can say that two electron gone to the next carbon. Now again you can see its effect. Now what will happen, where two electron gone adjacent carbon, then after that double bond was there, because single bond, double bond, again single, again double, again single. This is the actually I told you single and double bond in benzene ring. Then now this electron which pi bond broken, that came to the adjacent carbon, that will make, you can tell, that will make a double bond next to this carbon. Next to this carbon, they will make double bond. Means now that two electron made a double bond, and then next after this carbon, next was the double bond. Then again to maintain 4 valency of carbon, that pi bond will break and it will give to the next carbon. It will give to the adjacent carbon. Correct? Then now third structure, what will happen? Now you have shown only this thing. In second structure only you have shown the direction where electron will move. Now in third structure, again this double bond made. What was the double electron near this adjacent carbon? That will make double bond. And after that double bond was there, that will give to the next carbon. And there this electron will go to the pair of electron, pi electron. That after breaking the bond, that two electron which was in the nearest carbon, now they will make a double bond with the next carbon, in the structure third. Now see how movement of electron is going on. And again what will happen, that these two electron, now second double bond broken, and two electron gone to the next carbon, on carbon atom. Then now in the next structure means fourth structure, again what will happen, these two electron that will make a double bond, where single bond was there it will be double bond. And after that, what was the double bond? That will become single bond, and it will give electron to the next carbon, Then like this way, complete lone pair of electron of nitrogen moved on entire atoms of benzene ring. On 6 atom was there, then okay, first was NH2 itself was attached, then 5 carbon was there, then now lone pair of nitrogen moved in all 5, in all you can say 5 atoms. It went on all 5 atoms of benzene ring. Double became single bond, single became double bond. Like that way, there became lone pair of electron completely moved. This due to that lone pair of electron, complete adjustment took place to maintain the tetravalency of carbon through 4 structure. Then these 4 structures are called resonance structure. Then this is the effect. You can see that lone pair of nitrogen, that due to that lone pair of electron, how you can say their change in a structure took place. This is due to the effect. This is called effect, that due to the lone pair of nitrogen, all you can say this adjustment or disturbance also you can tell took place. That single bond became double bond became single bond. Like that way, in that way 4 structures formed. And here again important point, that when lone pair of electron, nitrogen lone pair of electron, when it moved, made double bond, then because it has given electron, that's why nitrogen will have positive charge. On entire in all 4 structure, nitrogen has positive charge. And now due to this electron movement started. Then finally when it came to the, you can say, this nearest to the nitrogen, by this rotation the double became single become double like that, then double became single in the end, then that carbon nearest to the nitrogen, it started from one side movement and reached to the next side near the nitrogen. From the left side it started and reached to the right side near the nitrogen with negative charge. Okay, then this is actually called plus R effect. Plus charge because nitrogen given the lone pair, and on nitrogen it became positive. Nitrogen became positive. That's why it is called plus R effect. Now negative resonance effect, you can see resonance negative minus R. Then this will be just opposite of this. Movement will be just opposite of plus R. Minus R is opposite to plus R. Here substituent group is in the plus R, substituent group was NH2 having lone pair of electron. Means it was able to keep the electron pair to make the double bond to the nearest single bond. Now here you can see in minus R effect all things will be opposite. Here substituent group they will lack electron. This substituent group lack this electron. It lacks electron, it wants electron. Hence it will try to take electron from the benzene ring. From the benzene ring it will try to withdraw electron or take the electron. This effect is observed when the transfer of electron is towards the atom or substituent group attached to the conjugated system. For example, in nitrobenzene, this electron displacement can be found. You can see, you can observe electron displacement. Just like first case plus R you have seen electron displacement, here also electron displacement will take place, but in a opposite way. Now electron will move towards the group, substituent group, or in that group some atom will be there. Towards that atom which need electron, there it will move from benzene ring. Okay. Then now just to consider these things, nitrobenzene. By nitrobenzene you can understand the displacement of electron, NO2. Then NO2 group, this is a electron deficient. It will take the, it wants electron. NO2 wants electron, particularly that N wants electron here. Then now suppose NO2 is attached to the benzene ring. Then NO2, both O are, one O is have double bond. O and N is double bond. Another O is a single bond, coordinate bond you can tell, coordinate bond towards oxygen. Electron will be N and O, single bond will be, that is the coordinate bond will be there. Arrow sign will be there because nitrogen has given oxygen electron, both electron, it has a lone pair of electron that is given to oxygen. That's why arrow sign is shown towards oxygen and formed a coordinate bond. Then in NO2, one oxygen is making double bond with nitrogen, and other oxygen is making one coordinate bond. Okay, and you can say this, and N is attached to the benzene. N is attached to the benzene ring. Then now 5 carbons are free. Okay, movement will take place through these 5 carbons. Then now you can see, now in this situation when NO2 is attached with benzene ring. Then three double bond is there and 3 single bond is there in benzene ring. Keep in mind. Then near the N is attached to the carbon, benzene ring. Then from that carbon, now you can start. That is a double bond. That is a double bond. And before double bond, single bond. Again, before that, double bond. Again, before that, single bond. Again, before that, double bond. Means 3 double bond and 3 single bond is there in benzene ring. And now just you can start with the first double bond. Means nitrogen is attached to the benzene, from that carbon. Then there this double bond is there. Only in the beginning double bond is there. From where N is attached to the carbon, that carbon has a double bond. Then now see, here also you will get 4 structure. 4 resonance structure you will get. Only you have to see the movement of electron, displacement of electron. Then now what will happen? That now this nitrogen require electron because its lone pair of electron is given to the oxygen to make the coordinate bond. Then now nitrogen is, you know that it is also an electronegative element. Then now it will take that it will electron of double bond, means pi bond will break here, and that electron will shift to the nitrogen carbon single bond was there, nitrogen carbon single bond. In that direction it will move. And in the second structure what will happen? That now it moved. First structure only you have shown the direction. From the middle of the bond, arrow sign was towards the single bond between N and C. Only you have shown direction. Now in second structure, actually this has been gone. Electron has been gone to the single. Now it became double. Now N and carbon became double bond. And because carbon has moved, hence adjacent carbon got positive charge. Adjacent carbon got a positive charge. Correct? And when it got positive charge, then now this carbon require electron. Then what will happen? Then next, what was the double bond? Actually, if you will start with the carbon number 1, with it attached to N, then from nitrogen attached to carbon 1, then carbon number 2, left side you count. Then there positive charge created. Then carbon number 3rd, double bond was there. Then this double bond, pi bond will break. In 2 bond, 1 bond is pi bond, other bond is sigma bond. You know all things. Then that double bond will break and it will give 2 electron to the second carbon which was positive charge. It will move towards that carbon. It will give to that carbon. Then there again it will become double bond. And here means fourth carbon will have positive charge. In second structure only direction you are showing. In third structure now it has this electron, both electron, pi bond broken and given to that carbon having positive there, and it made a double bond. Then now fourth is lagging behind electron. Now fourth carbon become positive. Then now what will happen? Fifth carbon will give electron to the fourth carbon. Then now here it will become double bond. And now fifth will become positive charge. Like that way, see how rotation is going on. Nearest carbon is becoming positive. And this again Adjacent carbon is giving electron, a pair of electron to the positive carbon, and there it is making double bond. Then here we can see how positive charge developed in a structure 1. Carbon number 2 got positive charge. Then this positive charge dispersed everywhere. It was on the second. After that it went to the fourth, and fourth. After that it went to the fourth, sixth. It went to the sixth. Okay, it started with 2 and it went to the sixth. Mean whole ring positive charge developed. And here one thing I want to tell you, NO2. Then one N was attached, one N and oxygen was having double bond, and other oxygen coordinate bond. Then here when this carbon number 1 double bond, which was first carbon number double bond, when it will make a bond with nitrogen double bond, that time what will happen, that N and O double bond was there, then that double bond will break. You have to show the curved arrow that now that double bond will break, because nitrogen and carbon is making double bond. Then now again this maximum 4 valency, maximum nitrogen can make, nitrogen also can make 4 valency maximum. Then now that's why this double bond N and O double bond was there. From that double bond will break. Okay, when bond will form between N and C double bond, then that will become single bond. With the single bond means 3 pair of electron will be there and negative charge will be there. Then in all three structure, this negative charge of NO2 will be there. Okay, after breaking 2 electron taken, oxygen only, and because oxygen they have electron they have taken. Oxygen taken the electron 1 pair of this after double bond, when bond becomes single bond, then 2 electron only oxygen has taken, that's why it became negative. Then in all three that NO2 has 1 oxygen has negative in all 3 structure, and positive charge dispersed from second to sixth, second, then fourth, and then sixth. Then here again you are getting 4 resonance structure, and complete positive charge is you can say moved from second to sixth, means electron displacement took place. In the first case, in minus R case, negative charge dispersed everywhere, and here positive charge dispersed everywhere. Okay, that's why it is, because now you can see everywhere negative charge is there on oxygen, NO2. That's why it is called minus R effect. The atom or subsequent group which represent plus R or minus R electron displacement, that this plus R or minus R electron displacement effects, now I am telling you that which are the plus R, means groups which can show plus R effect. Subsequent group, I am telling the name of subsequent group or atom which plays the role of plus R effect. Plus R effect is due to halogen. Halogen means maybe fluorine, chlorine, bromine, iodine. It can take the electron and will become negative. Then first example of plus R group, subsequent group for plus R effect, then that is the first example is halogen. Second example is hydroxyl, OH. It also withdraw the electron. Okay. Third example is OR. OR. Means electronegative element should be there, very simple way. And third example is OCOR. OCOR means what? O and C single bond, again C and 2 are there, then another second oxygen is double bond. Or simply tell OCOR. OCOR. But here one oxygen is a double bond. C and oxygen double bond. One is a single bond and other has a double bond. Both are making bond with carbon only. And R is also attached with carbon, OCOR. O is OC, O and C single bond, and C and O, another O is double bond. Then 2 plus 1, 3, valence is over, and fourth valence is with R. Then OCOR. And next example is NH2. Already I told you NH2, NHR, NR2, NHCOR, all these are the example of plus R. These are the, due to this substituent group, plus R effect takes place. Again I am telling the name one more time. Halogen, second is the OH, third is the OR, fourth is the OCOR, fifth is the NH2, sixth is the NHR, 7 is the NR2, and 8 last NHCOR. Okay, NHCOR last. This will show plus R effect. Question is asked in examination. Question is asked, and this you should remember always, because movement of electron or displacement of electron will take place according to this group only. Then now I am telling the example of groups or substituent which will show minus R effect. Minus R effect. Now that for minus R effect means it will take the group will take the electron, and in the first case plus R, that will give the electron. Okay, that will give the electron and movement will start. Already I told plus R minus R. Then plus R will start the effect. Okay, and minus R, that will take the electron. Means by taking the electron, effect will start. Then now first example of minus R effect is minus COOH. First minus means here COOH group, you can tell one valence is there. Means one open valence is there just to make the bond. Then first group is COOH. Second group is aldehyde, means CHO. Third group is carbonyl, CO group. Now two valences are opened. And the next is cyanide group, CN, C triple bond N, CN. And next is NO2 group. Then this also you remember always. Again I am telling, carboxylic group means COOH group. Second, aldehyde group means CHO. Third, carbonyl group, CO. Fourth, CN group. And fifth, NO2 group. The presence of alternate single and double bond in an open chain or a cyclic system is termed as a conjugated system. This alternate double bond and single bond may be in the long chain also, or in a cycle also, just like a benzene. Whatever example I given, that was in case of benzene. But alternate double and single bond may be in a straight line also. 4, 5 carbons are there. One will start with single bond, other will be double bond, again single bond, again double bond. Like that way, alternate double and single bond is possible in both cases, in open state chain or in cyclic chain. That is also called cyclic system. Then here the presence of alternate single and double bonds in an open chain or cyclic system is termed as a conjugated system. Now you can see these system often show abnormal behavior. This system often show abnormal behavior. The examples are 1,3-butadiene, 1,3-butadiene, aniline, and nitrobenzene, etc. In such system, the pi electrons are delocalized and the system develops polarity. Okay. Then this movement will start from the according to the group attached to the this type of system. Okay. Now I am going to discuss electromeric effect. Electromeric effect, E, as capital E effect, capital E. Then what is actually electromeric effect? It is a temporary effect. First question is that. First question will ask only that. It is a temporary effect. Electromeric effect is a temporary effect. Inductive effect is permanent effect. Now here it is a temporary effect. The organic compounds having a multiple bond means a double bond or triple bond. Any molecules or compounds having double bond or triple bond is called multiple bond. Then the organic compound having a multiple bond means a double or triple bond show this effect in the presence of an attaching reagent only. When they will see it is coming, some group is coming to attach or attack also you can tell, attacking reagent also you can tell, attacking reagent, then that time it will show some effect. Okay. This effect, mesomeric effect, not electromeric effect, that it will show when any attacking group or attacking reagent will come to this system, means multiple bond system, then it will show this type of effect, means electromeric effect. It is defined as the complete transfer of shared pair of pi electron to one of the atoms joined by a multiple bond on the demand of an attacking reagent. What will happen? They want electron. The effect is annulled by as soon as the attacking reagent is removed from the domain of the reaction. Then suppose reaction is going on and one attacking group is coming and it wants an electron. It wants electron or it wants to give electron also, anything. Then that double bond or single bond, a double or triple bond was there in that system, that their pi bond will be affected. In triple bond, 2 pi bond is there and 1 sigma bond, and double bond, 1 pi and 1 sigma bond. Then pi bond is bigger than sigma, you know. Then as soon as attacking reagent comes to that system, means multiple bond system, that time it will show this effect, electromeric effect. And when it will go, this group will go, this reagent will go, then that effect also will go. That's why it is a temporary effect. The effect is annulled annulled as soon as the attacking reagent is removed from the domain of the reaction. It is represented by capital E, and the shifting of electron is shown by a curved arrow. Curved arrow already I have told you. There are two distinct types of electromeric effect. First, positive, and second, negative. It depends upon the attacking reagent, whether it wants to give electron or it wants to take electron. According to that, this will be this is of two types, plus positive electromeric effect or negative electromeric effect. Then positive means then that it means attacking group will come and it will take the electron, means that attacking group wants electron. That why when it will attach to the system, then electron will try to move, try to displace towards that attacking reagent. It will move towards attacking reagent, and that system carbon will get positive charge. And in a reverse case, means in a negative electromeric effect, there it will be reverse case, because now electrons are coming. Then what will happen? When electrons are coming, then where electron will move, that will be negative. Correct? Then it is of two types. Then positive electromeric effect, I am talking about the positive electromeric effect plus E effect. In this effect, the pi electrons of the multiple bond are transferred to the atom to which the reagent gets attached. Okay, gets attached means, example I am giving you, that carbon-carbon double bond is there. Correct? Carbon-carbon double bond is there. Then now suppose any attacking reagent is coming, as for example H plus. H plus is coming. Then H plus, what it will do? It wants electron. H plus means it has no electron. What was only one electron hydrogen has, that also someone has taken. Now there is no electron with H, only H. That's why it has got 1 plus. And now it can take 2 electron. It can take 2 electron. Then when it will come to this carbon-carbon double bond, means so ethylene, it will come near to the ethylene, double C carbon-carbon double bond. Then this pi bond, out of 2 bond, 1 bond will break, pi bond, and that electron will be taken by hydrogen. That electron will be taken by hydrogen, and hydrogen will attach to that carbon, attach to the any one carbon, and other carbon will have positive charge. Okay, suppose with first carbon it is attached, then second carbon will get positive charge, and suppose it is attaching to the second carbon, then first carbon will get positive charge. Means electron gone to the H has taken the electron and attached to the carbon, then next carbon will get a positive charge. And reverse case is with negative electromeric effect minus E effect. In this effect, the pi electrons of the multiple bond are transmitted to that atom to which the attacking reagent does not get attached. Because now that attacking reagent is coming with electron. Attacking reagent is now coming with electron. It wants to give electron. Then where electron will move, there it will be negative. Then now suppose it is a same example, double bond, carbon-carbon double bond I am giving to open valence is there now. Then now suppose it is coming to the first carbon. It is attaching to the first carbon. Then what will happen? Second carbon will get negative charge, not the first. First it is attaching. Okay. Then what will actually happen, because this is coming with negative cyanide ion, as for example Cn. Then this electron, this one pair of electron will give to the carbon where it is attaching, but quickly that double bond will come single bond, and it will go to the, this electron will go to the nearest carbon, means second. If it is touching to the first, then second carbon will be negative. Second carbon will be negative, because 4 valence you have to maintain. Carbon has 4 valence, and then obviously that bond has to break. Then where, in this case, where group attacking group is attaching because it has lone pair of electron, means a negative charge, then what will happen? There it will give, that carbon will not have negative will be just adjacent second carbon. If it attaching with the first, then negative will go to the second, not the first, second, because bond will break and that electron will be taken by the second. That's why it will be negative. Okay. Then this is this I told you, this is because now here negative charge developed. That's why it is called negative electromeric effect. And in the first case, positive charge developed, because pi bond broken and that electron taken by the, as for example, hydrogen. That's why this first carbon, near the first carbon hydrogen came. It attached the first carbon. Then second carbon effect is there, positive. Means always where they are coming, where in both cases, wherever reagent is attacking, effect is on the second carbon. Effect is on the second carbon. First carbon in the first case, positive electromagnetic effect. In that case, they have given electron, first carbon given electron, then it has affected on the second, because bond broken and that electron is taken by the first one and second become positive. Now here reverse case in negative, where cyanide came with negative, then this has attached to the first carbon, then pi bond broken and that pi bond is taken by the second carbon. That is the negative. Effect will be of on other, charge will develop on other carbon, This is the important things I have given. I just explained on the by giving example. When inductive and electromeric effects operate in a, here important point I am telling you, when inductive and electromeric effects operate in opposite direction, inductive and electromeric effect, suppose only in one system both are going on, inductive effect and electromeric effect, then what will happen? When inductive and electromeric effects operate in opposite direction, the electromeric effect predominates. This question is asked. Electromeric effect will be more than inductive effect. This I have told you about the distance electromeric effect. And now hyperconjugative effect will take time. I will discuss in the next class. Okay. Thank you.